Here, we have an image of a bivariate copula. We have variable u1 and variable u2. Using this bivariate copula surface, we will discuss the properties that were previously introduced. One of the fundamental properties of a copula is that if at least one argument is 0, then the value of a copula is also 0. A specific case of this occurs when both arguments of the bivariate copula, u1 and u2, are equal to 0. In this case, since all arguments of the copula are set to 0, the value of the copula is also 0. Another important property is that if all values, in this case, both u1 and u2, are equal to 1, then the value of the copula is also 1. Next, we move to the boundary. Now, we consider the case where u1 is non-zero, but u2 is 0. In this situation, the value of the copula will always be 0. This means that if at least one of the arguments is 0, while at least one other argument is different from 0, then the value of the copula equals 0. In this case, u2 is 0, while u1 takes a value between 0 and 1. The same behavior can be observed in the symmetric case. Now, we have the reverse scenario, where u1 is 0 and u2 is not. And in this case, just like before, the same rule applies. If u1 is 0, while u2 is not, the copula's value is 0. This rule extends to higher dimensional cases as well. To summarize, if at least one of the arguments is 0, then the value of the copula is 0. Now what happens when we are at a boundary where one of the arguments is 1, while the other is not 0? Now u1 is 1, and u2 is not 0. In this situation, we can say with certainty that the value of the copula must be equal to the value of the parameter that is not equal to 1. In this case, the value of the copula is 0.38. This value is exactly equal to the value of variable u2. Now, let's move on to this other boundary. Here, we have a different situation than before. u1 is within the interval between 0 and 1, while u2 is 1. Again, we can see that the value of the copula is exactly equal to the value of the non-zero argument, which in this case is u1.